Okay, welcome back. Let's do this problem, which is an N6 integration problem, where we will need to use the technique of partial fractions. So you know there could be different possibilities there, but for this one, I check with the denominator and I realize what is happening there when the x squared plus 1 is a bracket. So I would prefer starting there where I have this, then I can always introduce this part and then plus I can say d over x plus 1 plus e over x plus 1 squared, and that equals x minus 1 over the bracket x plus 1 x squared plus 1. I could have taken C, D, but I just decided not to take the C. There's nothing wrong with that. You can use any letter for your A, B, D, E. You can use any letter there. Then this is the situation. Now we need to eliminate the denominators. When we eliminate the denominators, then we will have ax plus b into x plus 1 squared plus d into the x plus 1 as well as x squared plus 1 plus e into x squared plus 1, and this equal x minus 1. Yes, this only equals x minus 1. I'm trying to eliminate the denominators. So here I will see that for this bracket, or for this part rather, I will have ex squared plus e. Here I will have ex squared plus e. For this part I've got x plus 1 x squared plus 1. This gives me x cubed plus x plus x squared is x cubed plus x squared plus 1. So it's actually x cubed plus x squared plus x plus 1. This one here. So that is to the d. So I've got plus dx cubed plus dx squared plus dx plus d. Remember, d multiplies everything. So that is why I've got d that, d that, d that, d that. Plus, now I need to go to the e part. The e part, I have x plus 1 as x plus 1 bracket squared. So here I've got x squared plus x, which is 2x plus 1. But now this x squared plus 2x plus 1 multiplies x squared plus 1. So this is x squared plus 2x plus 1. It multiplies the, it multiplies the ax plus b. It multiplies ax plus b. Now I have ax cubed, that one. Then I have plus 2ax squared. Then I have plus ax plus bx squared plus 2bx plus b. Now this is all what I have, plus ax cubed plus this is cubed plus 2ax squared plus ax plus bx squared plus 2bx plus b equals x minus 1. It's something that needs you to be very, very concentrating when you're doing it. Now here I'm going to equate coefficients. In equating coefficients, I have to equate those ones, finally the constants. Now I need to check for all terms with this. So I've got my first one there as D, the second one is A, and there isn't any term, so this must be 0, because here there's no x cubed term. Now for x squared, I've got the E plus the G plus the 2A plus the B equals 0 still. The x's, I've got the D plus the A plus the 2B there, and this equals 1, because there is that x minus 1 there. Now that's D. Now for the constants, I've got the E is 1 plus D plus B, and this equals minus 1. So I have 1, 2, 3, 4. These are equations. But now, normally, what will happen is that after having dealt with this step here, after having done this step, maybe before even coming to this step, you need to at least establish one of these, so that now you are able to move quicker. But that doesn't mean that you cannot get all this if you did not do that. I'm just saying that most times it works easier, far better, quicker, if you establish at least one value of this. And how will you do that? If in there you say let x equal 1, if we say let x equals, no, not 1, but let x equals minus 1, then check if x is minus 1 here, this bracket becomes 0, because minus 1 plus 1 is 0. 0 squared will be 0. 0 multiplies now the bracket ax plus b, so this whole bracket falls down. This whole situation falls down. Again, if this x is minus 1, this bracket becomes 0. So everything there falls down to 0. Fine. So all this from here to there will fall down to 0. Now we come to this bracket. If this bracket is x is minus 1, what is minus 1 squared? Minus 1 squared is 1. So 1 plus 1 is 2. So I will therefore have 2e. All other things they are 0 except this part. If this x is minus 1, then I have this side as minus 2, because minus 1 is minus 2. Therefore, e equal minus 1. Now I know that e equals minus 1. Now if e equals minus 1, if e equals minus 1, then I know that e is minus 1. Then I need to work on all this. If this e is minus 1, then I can have db. Now if I have db, then I can always relate db with dA to get rid of d to get a, in order to get a. That I mean, you need to be very focused. From equation 4, e is minus 1. Then I've got plus d plus b equals minus 1. So you can therefore see that d plus b is 0. because this is common. Therefore, d plus c 0. Now this I can name equation, I've got how many before this, I can name equation 5. Now I can then take the d plus a equals 0, which is equation 1, this one, and then try to relate this. Now if I say equation 5 minus 1, what do I have? I've got d minus d, 0. I've got b minus a. What is b minus a? It remains as b minus a. And then, what is 0 minus 0? Is 0. So I have this other equation there, which I can name 6. It's not giving me any of the, I thought I was going to get A, but at least we haven't done anything wrong there. Now let's see, in D, A, B, D, A, B, E I know. So if this E is minus 1, I'm just trying to establish values, guys. There can be a lot of different methods. Then I can have D plus 2A plus B equals 1, because this minus 1 is transposed there. Now this I can name equation 7, but now I can then have D plus A plus 2B equals 1, which is now my equation 3. So what can I do with this? B minus A is 0. I need to come here and then say, what can I eliminate here? AB. If I eliminate AB, or if DB, let me eliminate A here. If I eliminate A, then I can go to equation 3 and multiply it by minus 2. And then I've got therefore minus 2D minus 2A. I'm multiplying by minus 2. Minus 2D minus 2A minus 4B minus 4B equals minus 2. Equals minus 2. So I have minus 2D minus 2A minus 2, minus 2D minus 2A minus 2A minus 4B equal minus 2. This I can name equation 8. This I can name equation 8. Okay, yes. That I can name equation 8. Oops. If I take down my equations, then where am I gonna work now? Let's see. If I have minus 2D minus A minus 4B equal minus 2 as equation 8, then I can relate this to equation 7, which is D plus 2A plus B equal 1. This is equation 7. So I can always add the 2. 8 plus 7, equation 8 plus that, I've got minus 2D plus D, it gives minus D. Minus 2A plus that falls down. This minus that, it gives minus 3B. Minus 4B plus B, it gives that. Minus 2 plus 1 gives minus 1. So this I can name my equation 9. I've got DB here. Where else do I have the dB? I've got the d plus b equals 0 as equation 5. Yeah, now let's add equation 9 plus 5. What do we have? This falls down. This minus that equals minus 2b. And then this then gives minus 1. Now therefore b equals 1 over 2. When b is 1 over 2, b is 1 over 2. B is 1 over 2. This b is 1 over 2. Now if I check from equation 6, where I'm saying b minus a equals 0, then this b, it being 1 over 2 minus a equals 0, therefore what is a? Therefore a is also 1 over 2. From here, a equals 1 over 2. So what do I need now? I've got E, D, A. I need D. Where can I get D? I can get D from equation 5. I can get D from equation 5. In equation 5, D plus B equals 0. This is equation 5. But I'm saying here that B is D plus 1 over 2 equals 0. Because B we have already. Now therefore D is 1 over 2. Now D is 1 over 2. So it is always a Fracrion that you will get all these values. So we have these values now. Now after having calculated these values, we now think back and then say, remember we have ax plus b over x squared plus 1 plus d over x plus 1 plus e over x plus 1 squared. Yes, remember we have this. This is what we must integrate. Now what is ax plus b? Ax plus b. So it's half x plus half over x squared plus 1 dx plus, what is d? D is minus 1 over 2 over x plus 1 dx plus e, what is e? Is minus 1 over x plus 1 bracket all squared. So this is what we must integrate. Now let's check. The first part, you would always try to check with the numerator denominator, but you will realize that you would need to break down. You would need to break down this part. And here you will need to take out common. You will need to take out common. There you would need to do this part. And there is then a whole lot of rules that must follow. I'm going to take this off so that I can have enough space. There. This part, you can take half out. Then you are left with x over x squared plus 1. The second part, you can take half out. So you are left with that part. The third part, you have simplified. This is 1 over x plus 1 dx. The last part is where you are going to work from basic principles. Now I can take this off. Now, finally the integral must be, if you check with the denominator, The first derivative is 2x, so if you say 2x there, then you need to counter on that. So this will then be ln x squared plus 1. The second part would be arctan x because of the situation. This one will be minus the ln of x plus 1. And finally here you have x minus 1 bracket raised to 1 over minus 1 over minus 1 plus c by the derivative of x, which is 1 there. Now finally, the answer written in more appropriate form will be that one plus half arctan x minus half the ln of x plus 1. Here you can see we have a plus, and this must be x plus 1 as a bracket plus the constant. Now this must be your integral there, integral there, integral there, integral there. So you see, you need to be working very, very closely. And that must be your integral. So for more of this, again, I will say you can always follow me there. But let me also say that for partial fractions, the most challenging thing is when you calculate those A, B, C, D values, because that's where now you need to work very closely so that you're not making mistakes. At times it is also necessary that when you have built on your equations and you have all the values, take those values, plug them in any of the equations and see if they balance out. The rule of thumb is that if you have an equation that has all the values in it, then that one is the one that we need to choose, and then plug all the values and see if you have all correct values in there. And thank you for watching on this. Thank you so much.